Okay, so here we have a 28.54 gram sample which contains 8.55 grams carbon, 1.07 grams hydrogen, 18.92 grams of chlorine. We want to find the empirical formula, which is the smallest whole number ratio. So we have to convert grams into moles. So 1 mole of carbon contains 12.01 grams of carbon, and that gives us 0.7119 moles of carbon. Same idea for hydrogen, 1.07 grams of hydrogen, 1.008 grams of hydrogen for 1 mole of hydrogen. And that gives us 1.06 moles of hydrogen, and then 18.92 grams of chlorine. Chlorine is 35.45 grams per mole. And that works out to be 0.5337 moles of Cl. And now we have the moles of carbon, the moles of hydrogen, the moles of chlorine, and we need a smallest whole number ratio. And the easiest thing to do is to take each one of these moles and that ratio is still a ratio if we divide all of them by the smallest number. That is 0.5337. And when we do that, 0.5337 divided by 0.5337 is, of course, 1. 1.06 divided by 0.5337, really close to 2, 1.99. We're going to call that 2 moles of H. And then 0.7119 divided by 0.5337 works out to be 1.33 moles of carbon. So in not whole number ratio, 1.33 moles of carbon to 2 moles of hydrogen to 1 mole of Cl, and what we need to do to make these a whole number, easiest thing is probably recognize 0.33 is 1/3, and so that sounds like a factor of 3 should work. So if we multiply each of these by 3, we still have the same ratio. 3 times 1.33 works out to be 4 moles of C. 3 times 2 works out to be 6 moles of H. And 3 times 1 works out to be 2 moles of, let's try that again. That's some crazy math there. 3 moles of Cl. And that means that C4H6Cl3 is actually our empirical formula.